Okay, so if we take this as our nuclear fuel rod, then we can imagine that down the centre we can stack small hockey puck-like shapes. Now these would be our uranium pellets, and these are what fission to produce the energy to power the nuclear reactor. Now it's important we keep these in a cylindrical stack, and this is done by use of a zirconium cladding material. Now if we unravel this zirconium cladding rod, and if we used an electron microscope to look at the microstructure, then what we would see is small circular regions repeating across the material. Now these are our grains, and they represent a different arrangement of atoms in each segment. Now in zirconium, we have a hexagonal arrangement of atoms, as shown by this unit cell here. So in each grain, we can have a different orientation of this arrangement of atoms. If there's a favoured orientation in the material, then this would be referred to as our texture. Now texture is quite important in a nuclear fuel rod because it dictates how long we can leave the rod in the nuclear reactor. However, my project is more interested about the processing of the material. So during rolling, we will compress the material and certain textures or orientations will be favoured. And I want to understand the mechanisms behind why certain textures are favoured, and hopefully I will improve the lifetime of nuclear fuel rods.